All right, so this is section 2.3, and this is going to be kind of a case study and kind of an introduction to probability. So chapter 3 is when we're going to talk about probability, and this is kind of an introduction to that. It's going to try to give you an intuitive sense about probability, and there's been a couple times where we've had some data, and there's been two different populations that have had different results, and we've kind of like hand waved about how different was the difference, and we're going to dial in a little more on that today. Not all the way, but we're going to be a lot better focused on that after this. Okay, so this is going to be looking at a case study from a gender discrimination study. So let me all right, so first, topics today to take notes on. We're going to introduce the idea of the null and alternative hypothesis. So make sure that this is one of your takeaways from what we talk about today. We're also going to talk about how to conclude a hypothesis test. Okay, this is really all about the scientific method in a way. And so what can you conclude after you've done a hypothesis test? You either reject the null hypothesis or fail to reject the null hypothesis. These are things it might be good to write down word for word, because these are things you're supposed to have word for word at the end of a hypothesis test. Somewhere at the end, you're supposed to say one of those things. You either reject the null hypothesis or fail to reject the null hypothesis. And we'll get more into that later. And then we're going to talk about simulations and a thing called the p-value, which is going to be really important for the rest of our class. And so we're going to talk about two-sided hypothesis test as well as like the steps of a hypothesis test. Okay, so this one, even though it's kind of a case study, it's also, these are all things we will be talking about for the rest of the class. So everything on here is stuff we're going to be talking, this is all very important stuff. Okay, moving on. We're looking at a gender discrimination study from 1974, which was in the Journal of Applied Psychology. And so it's almost 50-year-old study. So hopefully the oldness of it makes it not as controversial. All right. So in 1972, as a part of a study on gender discrimination, my little picture is in the way. 48 male bank supervisors were each given the same personnel file and asked to judge whether the person should be promoted to a branch manager job that was described as routine. The files were identical, except that half of the supervisors had files showing the person was male, and the other half had files showing the person was female. So, like I said before, you really can't, it's really hard to do experiments with people, because you can't just like assign half your group to be male, half your group to be female. And one way to get around this is to have imaginary people. So if you have imaginary people like this in this study, then you just kind of assign them. This person's male, this person's female, with identical things. And that's how you can create an experiment in this case. So, all right, it was randomly determined which supervisors got male applications, which ones got female applications. Of the 48 files reviewed, 35 were promoted. All right, that's a pretty good promotion rate. The studies tested whether females are unfairly discriminated against when it comes to promotions. Okay. Now, I already gave this one away. I always talk too much. All right, so is this observational or an experiment? It is an experiment because we have a treatment and a control. Okay, so here's the numbers. Take a look at them. So you've got 24 male and 24 female, and that's how you see like right there. And 35 were promoted and 13 were not promoted. And then if we look at the of the males, 21 were promoted, 3 were not promoted. And of the females, 14 were promoted, 10 were not promoted. So there's a difference there. We want to look at how big is the difference. So one way to kind of look at that is to change fractions into decimals. That's one way to start comparing the numbers a little bit better. So 21 out of 24 is 0.875, otherwise known as 87.5%. And percent of females is 14 out of 24, which is 0.583, otherwise known as 58.3%. Okay, let's do a practice question. We saw a difference of almost 30%, 29.2 to be exact, between the proportion of male and female files that were promoted. Based on this information, which of the below are true? A, so this could be multiple here. A, if we were to repeat the experiment, we would definitely see that more females get promoted. This was a fluke. B, promotion is dependent on gender. Males are more likely to be promoted. Hence, there's gender discrimination against women in promotional decisions. C, the difference in the proportions of promoted male and female files is due to chance. This is not evidence of gender discrimination against women in promotion decisions. D, I don't feel like reading number D, letter D. All right, so which of these are true based on the information we have? And the answer is B and C, maybe. So it could be B, it could be C. So for letter B, it's that promotion was more likely, hence there's gender discrimination. And then for C, this was due to random chance, and we don't know that yet. That's what statistics is all about, is determining which one of these it is in all sorts of situations, not just this study from 1970, but in all sorts of situations when you see a sample result that's different than what you expected or would have expected with a certain assumption, and you say, how different was it? So let's see. So there's two competing claims. So kind of B and C give us two competing claims that are both possible. And then we're going to kind of to C, try to find a way of determining which one seems more likely. So one claim is that there's nothing going on. And that claim is universal, basically. So promotion and gender, and then specifically in our situation, you might say promotion and gender are independent. No gender discrimination, observed difference in proportions is simply due to chance. Okay, so that's called the null hypothesis. The null hypothesis is almost always that there's nothing going on. Nothing's related. It was all a fluke. It was all random chance. That's what the null hypothesis is saying. Always. So in some of your homework problems are going to say, I was going to give you a situation kind of like this one and say, well, what's the null hypothesis? What's the alternative hypothesis? And the null hypothesis is always that nothing's going on. Nothing's related. Everything's independent. Then there's the alternative hypothesis. There's something going on. And in our particular situation here, it would be promotion and gender are dependent. There is gender discrimination, observed difference in promotions not due to chance. Okay, so null hypothesis is always that there's nothing going on, nothing's related. The alternative hypothesis is always that there's something going on, this is related. Okay, so the idea of the scientific method is going, and especially a statistical hypothesis test, resembles a trial. So the null hypothesis is that the defendant is nothing's going on, nothing's related, the defendant is innocent. The alternative hypothesis is that something's going on, something's happened, the defendant is guilty. Okay. We then present the evidence, collect the data, and we judge the evidence. Could this data plausibly have happened by chance if the null hypothesis were true? Okay. Now notice which one we assumed. Like not if the alternative hypothesis is true, if the null hypothesis is true. All right. So then it's either because, I think I'm going to say this later in the slide, just like a courtroom, you assume, like everyone's, at least in America, everyone is assumed innocent until proven guilty. And in statistics, everything's assumed independent until proven dependent. Okay? So I'm going to say that again, because this is the ultimate like metaphor for what we're doing the rest of the class, is that in America, you're assumed innocent until proven guilty. And in the hypothesis test, you assume everything's independent until proven dependent. Okay, so we have to kind of make this decision. We assume in a courtroom, we assume the person's innocent, and then say, how unlikely is it that they had the murder weapon and blah blah blah. Like, well, that's really unlikely. Okay, maybe they're guilty. And in our case, we assume nothing's going on, and we say, okay, well, how unlikely would it be to get results like this? All right. So if the evidence is not strong enough to reject the assumption of innocence, jury returns a verdict of not guilty. Now, notice in our court system, the official verdict is not innocent. The official verdict is not guilty. And there's a reason they do that in the courtroom, and there's a reason that we use a particular language in hypothesis test. Because it could be the case that the defendant was innocent, but there wasn't enough information to convict them. So similarly, in statistics, we say we don't declare the alternative hypothesis, we declare that we reject the null hypothesis, or we fail to reject the null hypothesis. So we never declare the null hypothesis to be true because we simply don't know. We gave it the benefit of the doubt in how we set it up, and so we don't declare it to be true. Okay, so never, ever, ever say you accept the null hypothesis. You will get 0 points on your homework or the test. Okay, all right. In the trial, the burden of proof is on the prosecution. In the hypothesis test, the burden of proof is on the unusual claim, so the claim that something's related. So the null hypothesis should be like the ordinary state of affairs, status quo. So remember that for the homework problems. The null hypothesis is usually nothing's going on, or it's the status quo. Okay. So the alternative hypothesis is something unusual or something's related. So null hypothesis H0 represents status quo. Just to recap here, the alternative hypothesis represents our research question, like usually testing to see if something's related. So we conduct a hypothesis test under the assumption that the null hypothesis is true. Okay, so today we're going to do that via simulation. Later on, we're going to learn some more mathematical, theoretical methods. Okay. If the test results suggest that the data do not provide convincing evidence for the alternative hypothesis, we stick with the null hypothesis. If they do, then we reject the null hypothesis in favor of the alternative. Okay, so under the assumption of independence, i.e. leaving things up to chance, if the results from a simulation based on the chance model look like the data, then we can determine that the difference between the proportions of promoted files is simply due to chance. So we're going to do some simulations coming up, and we observed in that study from 1970s that the difference of proportions was 30 percentage points. And so we want to know, is it normal, like under random chance stuff, like setting up a simulation where everything was random, would you see a lot of like 30 percentage point differences between two samples? Or is that unusual? Okay, if the results from the simulation based on chance model do not look like the data, then we can determine the difference between the proportions of promoted files between males and females was not due to chance, but due to an actual effect of the gender of the respondents in this case. And in any other case, it would be, whatever the alternative hypothesis was saying. Okay, now, if we were in class right now, I would have decks of playing cards and divide people into partners. So if you have a deck of cards at home, go get it now. This will, the tactileness of touching something will help you remember this better. So do it. Pause the video and go grab a deck of cards. All right, so we're going to let a face card represent not promoted, and non-face cards represent promoted. And then we're going to count ace cards as face cards. So, and forget about jokers. So take the jokers out. So then we need to make this fit the actual data. So take out 3 aces. So then there should be 13 face cards left. There should be 4 jacks, 4 queens, 4 kings, and 1 ace. Okay, after you've taken out the 3 other aces. And then take out a number card. So then there should be exactly 35 non-face number cards in the deck. So those are the cards 2 through 10. Okay, so now we have the situation where we have those, like in the study, there were the 48 resumes, right? And if nothing's related, then it doesn't matter if they're male or female. Okay, so then we only just know that 13 were not promoted and 35 were promoted. So divide your cards into promoted and not promoted, and then we're going to deal them like to male and to female. All right, so shuffle the cards and deal them into 2 groups of size 24, representing male and female. So count and record how many files in each group are promoted. So count and record how many number files in each one. So I'm gonna and then we're going to calculate the proportion of promoted files in each group and take the difference, male minus female, and record this value. Okay, then we're going to repeat step 2 through 4 many times. And in class, I would have had everyone doing it. We would have had a very large sample size. So I'm going to do it once, and then I'm going to use a spreadsheet to do the rest of my simulation. All right, so just to recap, take a deck of cards. Take out 3 aces. Take out 1 number card. Your number cards are promoted cards, and your face cards are not promoted. And then deal them into 24 male and 24 female. And then record, like compute the fraction of how many were promoted, and then compute the difference. Okay? All right. I'm going to pause the video now, and I'm going to grab a deck of cards.